Hello everybody, so today I will do the practice of design Ticketmaster again. So let me get started with functional requirement. So because this is the Ticketmaster, so ticket booking site, obviously user has to be able to search the event. So I would say user can search an event. So he can search the event from maybe from area, and also maybe from the date, and also from keyword. So let me make it the functional requirement. And also, user should be able to view the detail of the event page. And also, obviously, users should be able to purchase the ticket. Okay, and one more, I will be a bit more specific. So users should be able to purchase a ticket, and this ticket is booked for a specific seat. So it's not like the, area, or should I say zone of the ticket. Like, so yeah, for example, if we go to the concert, maybe you make the booking for the kind of S area, A area, B area. But in my design, I will make it per seat. So like 16A, 16B. Okay. Next, function requirements. So I will think of the CAP theorem first. So in CAP theorem, consistency versus availability versus partition tolerance. I can choose 2 of 3. So because I will design the distributed system, partition tolerance is the must. Because if partition tolerance is not guaranteed, what happens is that if there is a network loss, the whole system goes down. Whole system dies. Obviously, this is not something I can accept. So I have to choose consistency. I should say strong consistency versus availability. So I will do a quick comparison between the prioritizations. So if I choose strong consistency, let's think of the database. So let's say there is a data in the primary node and there's a replica data in the replica node. So consistency essentially is every reader should be able to read the latest write. So let's say there is a master node and replica node, and there is one process that updates the master node. And that data is copied into the replica node. So if I choose a consistency, that should be, that copy should be synchronous. So once the data is written into the master node and then replica node synchronized, I can say the read is done. And from the next moment, even if the writer reads from the replica node, it can read from the reader process can read the latest write from the writer process. So this is a consistency. So what I mean by, but if I choose this consistency, if there is, what should I say? So, yeah, so if there is a kind of, network disconnection between master node and replica node, if I try to, consist in strong consistency, data copy is not available. So we should not accept the read request. So in that way, we cannot guarantee the availability because, data is not available. But if I choose availability, what happens is that I accept not strong consistency, but only eventual consistency. So data is copied asynchronously, and even if there is a network disconnection, replica data is returned even though it is a bit outdated. In that way, the system, the data is available all the time, but they are not strongly consistent. So that's the case if I choose, prioritize consistency over availability. And that being said, for Ticketmaster, basically the main part, ticket booking, I have to guarantee the strong consistency. So if I don't guarantee the strong consistency, what happens is that in the system, in a part, a seat is available, let's say first. And then there is a kind of process, which is a user client, tries to book that seat. And it is booked for that user. However, there is another process, which is a user, which sees that seat data, and because, if strong consistency is not guaranteed, the reader, the other client reads from the outdated data, and because it is outdated, the seat is available, and the other process, that process can book another ticket for the same seat. Obviously, this is not something we can accept, so we choose strong consistency for ticket booking part. However, aside from that, I will choose the availability. Okay, so for example, let's think of the event description. So there is an admin user who updates the event description. So there is a write operation onto the data. But let's say there is a user who just updated the page, in the front end, and the description is a bit outdated, not the latest one. It's totally fine. Instead, I should guarantee that if something, if there is a network disconnection, the reader should be able to read always. The reader should be able to read the data always, even if it is a bit outdated. So in that sense, I guarantee availability and accept the eventual consistency. Okay, so another non-function requirement here is, so what is necessary? Yeah, maybe row latency. Let's go with this. So even for booking the event, even for purchasing a ticket, I try to guarantee a kind of row latency, like within 500 millisec. So 500 millisec is something user doesn't feel stressed in a typical web application. I can say if it is 50 millisec, user feels that it's very fast. But if it takes 1 second for something, user feel it's slow. So I take the middle ground, 500 millisec here. And I will guarantee the scalability. So I will, the system should be scalable until 100 million daily users, 100k event per day. maybe 100 times spike. So why there is a spike in this system? So it is because let's say the Taylor Swift announces the concert and the announce date is already decided. So let's say there is a banner advertisement like Taylor Swift will announce a new tour on May 1st. In that case, so many users comes into the see the announcement of the event on May 1st, so there should be a spike. Or obviously, if the ticket is announced to be sold on maybe May 15th, many people usually comes to the website to make the booking on May 15th at 0 a.m. at the exact time. So that's why obviously we need this spike. We need to handle the spike in this system. Okay, so now I will talk about core entities. So core entities is something like the table names of the database. So I will clarify which entity is necessary, but for attribute of them, I will talk about it later. So for entities, we need the user who makes the booking and also event. And event is held in the place, which is the venue. And also event has the performer. And if there is an event, there is a seat to be sold. So I create the seat entity, and I will be clear on this. So for each event, every time there is an event, seat is created. So Taylor Swift concert, seat for the Taylor Swift concert. Wait. Okay, let me change a little bit. So I would say seat is always associated with the venue. So I will call it venue seat. So it like the physical seat, like the Dodger Stadium 16A seat. And if there is a if the event is announced, the admin user creates the booking record. So let's say ticket record. So ticket is basically one ticket is associated with one venue seat. So that's the kind of information for ticket. So ticket is almost like the booking. Yeah, maybe I should call it booking. It is fine because ticket is, I can say, the physical entity of the booking. The paper ticket here. Okay, so these are core entities. So I will do the API design here. So I will take a look at each function requirement. So firstly, user can search event by area, date, and keyword. So obviously I need get event, or I should say search event. So here, user searches with get when user inputs the search condition in the web UI and hits the search button, the request should be thrown to the backend. And the backend should have the search event API, which looks like this. Yeah. Okay, so let me just say date here. Yeah, I'm pretty sure this isn't the most important discussion point here, so I will make it a bit more clear here. So, and this API doesn't need the authentication or authorization. Everybody, even if he's not logged in, should be able to search event. And we should return the list of events, which should be rendered as a search result in the UI. And the second API is get event API. So this is necessary because when user opens the event page, he should be able to see the details of the event, like date, description, venue, performer information, or something like that. So I will create the backend API for this. This is quite simple, something like this. For this one, we don't need the authentication either. So number 3, okay, so I said user can view the details of the event, and also he'd like to see the seat availability here. So like 16A is already booked, or 16B is still available, or something like that. So there should be the whole, maybe the availability of the whole seat, or maybe according to the specification, specific area, because user chooses specific area of the seat in the UI, and the detail, it zoomed in, kind of zoomed in seat picture is shown, and the availability should be displayed. But anyway, the thing is, we need the seat availabilities. So I will say get ticket, because as I said, seat is physical entity, so get ticket, I would say. So this is it, and it should return the ticket, list of ticket. Okay, let me change a little bit. So now I'm determined to define event seat here. Oh, sorry. And I would say this is booking. So event seat is just the availability, and this is created when the seat, admin user creates the new event. And this is the booking information, which stores which user booked it, or something like that. Event seat is just the physical kind of, seat number, and maybe if it is already booked or not, those simple information is stored. But for booking, this has more like user ID and maybe booked out, and maybe in the concert, if he finally appeared in the concert or not, that flag should be stored in this table. So that being said, what I need is this event seat, available or not, basically. And number 4, user can purchase the ticket. So here, what he'd like to create is a booking. So because, okay, so sorry, just one more comment on this. Even though this just a seed, because this is nested inside of the event, this obviously tells that this is the event seed. Okay, and I come back to number 4, so purchase ticket. So for each event, for each seed, I'd like to create a booking. So I create a post API, and booking is created for each seed. But no, I need a seed ID. Okay, so this is it. And probably I don't need event because, or I should say event seed, I would say. Yeah, so when I say event seed, this point to exactly event seed entity, which is nested inside of the event. So this is good enough. And here, purchase should be able to be done only by the login user. Yeah, it totally depends on the specification, but for most application, if user would like to purchase something, he should be logged in. So I will take that specification in this case. So header should be auth token. This should be in the authorized header. This includes user ID. And it should be, kind of verified in the backend that the signature is correct and it's not, tampered. And if this returns 204, booking succeed or booking failure. Yeah. Okay, so this is the API design. Now I go into the high-level design. So in high-level design, I will try to realize each API one by one. So let's get started with search event. So there is a user who'd like to make the booking, and the request should firstly go to the API gateway and go to the service. So I take the microservice architecture here. So okay, and there should be, search. So, this search service makes a query to the database and gets a search, result. So here, I will use the Elasticsearch because I need a keyword search. So if I use the, let's say, PostgreSQL, and if I try to find the search keyword like Taylor or maybe rock music or something like that, the query has to scan all the B+3, or I should say all the column data of the PostgreSQL. It's a full scan, so it takes tons of time. So I want to avoid it. So what I really need here is the inverted index. So inverted index is kind of basically keyword, the mapping from keyword to the record. So, and Elasticsearch is basically the most standard for that purpose currently, so I use the Elasticsearch here. So here, inside of the Elasticsearch, event data should be stored. But Elasticsearch is not used for the primary DB. Basically, this is the kind of secondary data kind of replica, purpose-built DB. So I need the main data to store somewhere else. in maybe PostgreSQL or maybe in NoSQL. Let's call it EventsDB, and I use PostgreSQL here. I will change this to the more specific appropriate DB if necessary. Like I will change it to DynamoDB or maybe Cassandra later. But for now, what I need to do is just store the event. So I use PostgreSQL here as the default because it's very standard nowadays. So what happens is when there is event, event is decided to be held. Admin user creates the event recode, and this Elasticsearch, we use the change data capture to store the main data changes to Elasticsearch, and search service fetches the event from Elasticsearch. So this is it. And here, obviously, we need event table. We need performer. We need venue. We need venue seed. I will omit it because it's one time only when, yeah. And event seed, and book. Yeah, these are things I need now. Even I don't need event seed even now. What I need is basically events table, because yeah, we just want to search events now. Okay, so this is the high level architecture of search event API, and I will talk about get event API. So I will just name it to event service, and I will also return get event from this event search. Okay, and next thing I will do is get ticket. So, although I did get ticket. Okay, so get ticket. Okay, so what I need to do is we'd like to fetch the get event and also in this type get ticket. So firstly, I need the ticket table. Sorry, I will add something here. So here we need ticket ID and event ID and availability. So let's say booked at, because I mean, if booked at is null, sorry, let's say user ID and booked at. So now I can say if user ID is null, the ticket is available. If ticket is not booked yet, user ID should be null. So this should be returned. Obviously, I don't return user ID in the mapping. So this is actually only the list of is booked Boolean flags. But anyway, so now I can say this should also, sorry. this should also be able to support get ticket. So basically this is a kind of quite basic SQL query to get ticket from specified event ID. Okay, so now I will talk about the purchase ticket. So purchase ticket is something user tries to purchase a ticket with the credit card. So I will talk about the case of credit card, but maybe in a more extended cases, users should be able to purchase with maybe Apple Pay, Google Pay, or something like that. But for now, I use a credit card. So I will use the external payment system like Stripe. And I will tell you why. So if we'd like to do the payment system all internally, we have to store the credit card data in a backend. And there is a very strict PCI regulation if we'd like to store the credit card in a database or in a servers. So most startup companies kind of do outsourcing this payment system, something. So that's why I'm thinking of using the payment system like Stripe here. So how this payment system like Stripe works is that there is a kind of frame, in the UI, when user proceeds to the purchase page, there is a iframe shown in the displayed in the UI. So this iframe I can think as the kind of independent process in the browser, which is independent from the outer UI. So when user inputs the card data, that iframe directly sends the card information to the payment system. Without going through our backend. Of course, the card data is encrypted, and and what happens is that the third payment system returns a token. So payment system stores the card data, and instead, the token, payment token, which is a kind of identifier of the card data, is returned to the user. And now with the token, user makes a request to our backend to make the payment. So I will show you how. So this token is sent to the booking system, booking service. And here, booking request is made with the payment token. Then what happens is that this booking service makes a request to Stripe to make the purchase. So this request knows which seat he'd like to book. So, and also the price of the ticket. So the price of the ticket is obviously the amount of money to be withdrawn from the credit card. And event ID or user ID, seat ID is something very important later. So it includes it as the metadata. And this payment system, when the payment is done, from the credit card basically makes the webhook. It's the most common pattern now. So it now sends a webhook and we will receive the payment webhook receiver service here. And as I said, this includes user ID or seat ID, so as the metadata. So now this payment webhooks update the ticket user ID and booked ID. So this is the basic flow. Obviously, seat and token and seat ID. Okay. So in this way, booking is done. But there is one problem here. So this is very bad experience for users. So let's say there is one seat and there is two users who'd like to make the booking. In that case, the first user makes the payment and finally tries to book the ticket. And it is available, so he can book the ticket. But another user, after making the payment, fails to book that ticket because that ticket is already taken. In that case, what happens is that our backend processes a refund to that user, and user fails to book. So the bad point are, number one, user may input the card information and took their time to make the payment, but it finally fails. It's a waste of time. And number two, user, so in the credit card history, payment history, he can see number one, payment, and then refund for the ticket he failed to book. This is very bad experience, so I'd like to avoid it. So what we can do is kind of introducing the grace time. So when some user kind of chooses the seat, he's given, let's say, 10 minutes of grace time, and he has to make the payment within the 10 minutes. But if he couldn't finish it in 10 minutes, that seat is now available to other users. So that's what I'd like to introduce here. So basically, this is not so hard to realize. What we would like to do is here secured until and secured by, and also we need booked at and booked by. Okay, so let's say the seat is firstly secured. Okay, so this is like the state machine. So book is firstly available and then secured and then booked. So we use the secured until and the secured by to clarify if it is currently secured or not. And then this booked at, booked by, this is the final status on who made the booking. So this is what I will introduce as the attributes of ticket table. So in this way, we can use the when, what should I say? When user chooses the ticket, they double check the secured until, and if secured until has some value and it is greater than now, that seat is not available to be booked. Okay, and because secured until, this is set with, okay, so when user chooses the seat to make the payment, secured until is set with that time plus 10 minutes. In that way, we just take a look at secured until timestamp, and then we can know that the ticket is still secured or not. So we don't need something like TTL or something like that. So this is, I think, a good idea. Okay, so now I talked about the payment, purchase ticket API, and also I talked about the grace time of the booking for payment. Now I will talk about this one, strong consistency. So how can I make sure that there are two users who makes the double booking? So what I firstly would like to clarify in which case this double booking occurs. So it occurs when number one, user A fetches the ticket status and user A secures the ticket. So this occurs. Oh, by the way, I forgot to say something like this. I said I will make it like the state machine, but if I can guarantee that there is only one user always who can proceed to the secured status for the ticket, then only that user can proceed to the booked status. So I have to think of the strong consistency for the state transition from available to secured. Because so now my discussion is all about how I can guarantee the strong consistency for securing the ticket. So and that being said, when user tries to secure the ticket, it happens in this way. And let's say there is another user who do it in this way. So if this event occur in this order, there's no problem, because when user A secures the ticket, this is basically this doesn't occur. User B read it as secured. So it's okay. But let's say there is a time that these two operations are intertwined to each other. So user A reads the ticket status and is not secured. User B reads the ticket status, not secured. And now user A secures the ticket, user B secures the ticket. So this is fine. And what happens is that user B now here, what happens with this user B, the last event is, operation is, this process operation updated secured until and secured by, even though they are filled with user A's valid security values. So this is exactly what I'd like to avoid. And to avoid that, there are a few ideas basically. Number one is using the database, or I should say our DB's isolation level serializable. I use this. Oh. And the second option is using the optimistic rock. And the third option is, okay, let me, pessimistic rock. So I will explain from pessimistic rock first. Okay, so number one, RDB isolation level serializable. So basically, before doing this, I will do this operation and this operation, so read and write in the same transaction. And that being said, if I set the isolation level serializable for RDB, what happens is that all the transactions are processed in the serializable way. So I can think of this just like they are processed one by one. Just to be clear, this is not linearizable. So when it is linearizable, it looks like transaction is completely one by one, like queries are waiting in the waiting queue and query is processed one by one. But for serializable, it doesn't guarantee that strong sequentiality, but serializable means that I can think of the data transition as if the transaction occurred one by one in the serialized way. So this means that, this doesn't occur. Okay, so this is solution number one. And solution number two is pessimistic rock on row. So this is using the, okay, so firstly, the reader starts the transaction and use the select for update statement to get the, when he gets the ticket data, and then he tries to update that ticket data. But when when he tries to select for update, he has to get the row rock, and every user who tries to secures the ticket tries to get the rock on the recode, on the row level, which means that this doesn't occur because user A gets the row rock, and now user B cannot get the row rock, so he has to wait until user A does this one and then ends the transaction, which releases the rock from user A. So this is pessimistic rock. So I can say queries are waiting in the waiting queue to be processed. And number three, optimistic rock on row. So I use the version key here. So ticket record has the version key now. And when user reads the status, ticket status, this version key is also read. Let's say version key is now 3. And when he tries to secure the ticket, he throws the right query, which specifies where version key is 3 and update version key to 4 as long as secured until and secured by attribute. In this way, if there is another process, client, which already updated version key, the client cannot find that record, so he cannot update. So he has to fetch the latest ticket record and retry again. So that's the optimistic rock. And that being said, I will compare this. So isolation level serializable is performance, the worst performance, because it handles the query which is thrown to the table one by one. So every possible seat query can be the blocker of another seat booking. So this is terrible in terms of the performance. So I don't choose it. For number 2, pessimistic rock, this is a little better because this is a raw rock. So if there is multiple client who'd like to secure the same seat, they are waiting in the waiting queue. Waiting queue for each record, each row. So this is good, but actually the seat is available for only one user. So the query, which is second or latest, doesn't have to wait. So that's a problem. But for optimistic rock, only the first one succeeds and the latter ones all fail. If they're, obviously, if they are thrown in the same time. But it's okay because, as I said, seat is available for only one user. So for the request which couldn't book the seat because that seat is just taken by another user, they don't have to wait. The query don't have to wait in the queue. So in that way, I can say optimistic rock is more performant. So I will go with this in this scenario. Okay, so now we've justified how I can, guarantee the strong consistency for locking, especially secured until and secured by columns. Yeah, in a scenario. Okay. So aside from that, for others, as I said, I'd like to guarantee the eventual consistency and availability. So for availability, I can, horizontally scale the booking service. Servers and maybe database with read replicas, Elasticsearch with replica 2, and API gateway is already redundant because it's a kind of cluster with servers internally. Yeah, so that's something I can say. Okay, so that being said, I quickly did the high-level overview of the Ticketmaster design. And also I talked about how I can realize the grace time for the payment, and also how I can guarantee the strong consistency with optimistic rock for the booking. Okay, that being said, I finished my today's practice. Thank you so much. Bye bye.